Oxygen. Oxygen exists freely in the atmosphere as a gas. Its chemical symbol is O. Two atoms of oxygen combine to form a molecule with a chemical formula, O2. Oxygen is also found combined with other elements such as hydrogen in water and metals in metal oxides. It is the most active component in air. Oxygen can be prepared in a laboratory as explained in the following experiment. Experiment. How oxygen is prepared in a laboratory. Let us observe this experiment to learn how oxygen is prepared in a laboratory. In this experiment, manganese 4 oxide is put in a flat-bottomed flask as shown. Hydrogen peroxide is added into the flask drop-wise using a dropping funnel. The first few bubbles are allowed to escape, then the gas is collected as shown. The color and the smell of the gas is noted. A glowing splint is lowered into the gas jar containing the gas. Hydrogen peroxide decomposes slowly to produce oxygen and water under normal conditions. On adding manganese 4 oxide, the rate of decomposition is speeded up. Manganese 4 oxide acts as a catalyst. A catalyst is a substance that alters the rate of a reaction. Manganese 4 oxide is used as a catalyst in the decomposition of hydrogen peroxide. This can be represented by this equation. The first few bubbles of oxygen are not collected because the gas is mixed with air which was originally in the flask. Oxygen is a colorless, odorless gas, with a low boiling point of -183 degrees Celsius. It is slightly soluble in water and so it can be collected over water. Oxygen relights a glowing splint. This is the test for oxygen. Oxygen can also be prepared in the laboratory by adding water to solid sodium peroxide using the setup below. Heating potassium manganate 7. Potassium permanganate. Burning of substances in air. Burning is the most familiar chemical reaction of air. As already established, oxygen is the active part of air, which supports burning. Many substances burn in the air. Example: some metals like sodium, calcium, magnesium, iron, and copper. Metals burn and react in air in different ways. To learn how metals burn in air and oxygen, let us observe these experiments. Experiment: how metals burn in air and oxygen. In this experiment, a piece of sodium is warmed in a deflagrating spoon until it begins to burn. It is then lowered into a gas jar containing air as shown. The gas is allowed to cool. Water is added to the product and the mixture is shaken. The gas produced is tested with moist red and blue litmus paper. The solution in the gas jar is tested using litmus papers. The experiment is repeated using oxygen instead of air. The whole procedure is repeated using calcium, magnesium, iron, and copper instead of sodium. Many metals burn in air and in oxygen at different rates. They burn faster in oxygen than in air. Nitrogen is the component of air, which slows down the rate of burning. Reaction of sodium when burned in air and oxygen. Sodium is a soft, silvery white metal. Sodium burns in air with a yellow-orange flame with few sparks. It burns in oxygen with a very vigorous yellow-orange flame. Sodium burns in oxygen to form sodium oxide, a white solid. It reacts with the nitrogen in the air to form sodium nitride, a yellowish or grayish solid. When dissolved in water, sodium nitride forms sodium hydroxide and ammonia gas, which turns litmus blue. Reaction of calcium when burned in air and oxygen. Calcium is a silvery white, soft metal. Calcium burns in air with an orange flame, and in oxygen with a vigorous red flame. The burning of calcium in oxygen forms calcium oxide, a white crystalline solid. Calcium reacts with nitrogen in the air to form calcium nitride, a pale yellow or brownish solid. When dissolved in water, calcium nitride forms calcium hydroxide and an alkaline gas, ammonia, that turns litmus blue. Reaction of magnesium when burned in air and oxygen. Magnesium is a silvery white metal. Magnesium brightly in air with a white flame, and burns more vigorously, with a glaring flame in oxygen. Magnesium burns to produce magnesium oxide, a white powder. It burns in nitrogen to form magnesium nitride, a dark gray or black crystalline solid. When dissolved in water, magnesium nitride forms magnesium hydroxide and ammonia gas, which turn litmus blue. Reaction of iron when burned in air and oxygen. Iron is a silver-gray metal. Iron has no apparent burning in air but glows red with few sparks. It glows more brightly with sparks in oxygen. Iron burns to produce iron 3 oxide, a red-brown solid, which is insoluble in water and has no effect on litmus paper. Reaction of copper when burned in air and oxygen. Copper is a reddish-brown metal. Copper does not burn in air but its surface turns black. It burns in oxygen with a blue flame that turns the surface black. Copper burns to produce copper 2 oxide, a black solid, which is insoluble in water and has no effect on litmus paper. When metals burn in oxygen, they form metal oxides. For instance, sodium burns in oxygen to form sodium oxide. Calcium burns in oxygen to form calcium oxide. Magnesium burns in oxygen to form magnesium oxide. Iron burns in oxygen to form iron 3 oxide. Reactive metals such as sodium, calcium and magnesium react with nitrogen in the air to form nitrides. For instance, Sodium reacts with nitrogen to form sodium nitride. Calcium reacts with nitrogen to form calcium nitride. Magnesium reacts with nitrogen to form magnesium nitride. When the nitrides react with water, ammonia gas is given out. For instance, sodium nitride reacts with water to form sodium hydroxide and ammonia. Calcium nitride reacts with water to form calcium hydroxide and ammonia. Magnesium nitride reacts with water to form magnesium hydroxide and ammonia. The reactions in which elements combine with oxygen are referred to as oxidation. The substance to which the oxygen is added is said to have been oxidized. Reactivity series of metals. Metals can be arranged in order of their rates of reaction with oxygen from the most reactive to the least reactive. This arrangement is referred to as reactivity series of metals. Mercury, silver, and gold are less reactive than copper and are not easily oxidized. Potassium and sodium reacts most vigorously with oxygen. Experiment. What happens when non-metallic elements burn? To learn what happens when nonmetals burn, let us observe this experiment. In this experiment, sulfur is heated in a deflagrating spoon until it begins to burn. It is then lowered into a gas jar of oxygen and observations are noted. A little water is added to the product and the mixture is shaken. The resulting solution is tested with a litmus paper. The experiment is repeated with carbon, charcoal, and red phosphorus in place of sulfur. Sulfur burns in oxygen to give a gaseous product which has a choking, irritating smell. The product is sulfur 4 oxide. A solution of sulfur 4 oxide in water is acidic and turns blue litmus paper red. The acid is called sulfuric 4 acid, sulfurous acid. Oxides that dissolve in water to form acidic solutions are called acidic oxides. Sulfur burns in oxygen with a blue flame to form sulfur 4 oxide, a gas that appears in the form of white fumes, and turns litmus red. Carbon burns in oxygen with a yellow flame to form carbon 4 oxide, a gas that appears in the form of white fumes, and turns litmus red. Phosphorus burns in oxygen with a white flame to form phosphorus 5 oxide and phosphorus 3 oxide, which appears in the form of white fumes, and turns litmus red. Some nonmetallic elements form oxides which are neither acidic nor basic. These oxides are referred to as neutral oxides. Carbon 2 oxide and water, hydrogen oxide, are examples of neutral oxides. Experiment. Is there a change in mass when substances burn in air? To learn whether substances change in mass when they burn in air, let us observe this experiment. In this experiment, about 1 gram of magnesium ribbon is put in a crucible and the apparatus set up as shown. The crucible is heated and the lid is lifted occasionally to let air in. No content is allowed to escape from the crucible. When all the magnesium has burned, the crucible is allowed to cool. The crucible and its contents are weighed again. The observations are recorded as follows. Mass of crucible plus magnesium before burning. Mass of crucible plus magnesium before burning. Mass of crucible plus magnesium after burning. When magnesium is burned in a closed crucible, most of the oxygen inside is consumed. It is therefore necessary to allow air in so that burning can continue. The mass of the product is more than the original mass of magnesium. This shows that as it burns, magnesium combines with air to form a new product. When substances burn in air, they combine with oxygen to form oxides. If the product is a solid, there is an increase in mass. When the product is gaseous, there is decrease in mass. The decrease in mass is because the products, being gaseous, escape into the air. Experiment. How do elements compete for combined oxygen? To learn how elements compete for oxygen, let us observe this experiment. In this experiment, copper 2 oxide is placed in a bottle top. Magnesium powder is added and mixed well. The mixture is heated and observations made. The experiment is repeated with magnesium oxide, zinc oxide, iron 3 oxide and lead oxide. The experiment is again repeated with lead, copper, zinc and iron in place of magnesium. Magnesium combines with oxygen more readily than copper. Therefore, magnesium removes combined oxygen in copper 2 oxide to form magnesium oxide. Copper is said to have been displaced by magnesium. Copper, on the other hand, does not remove combined oxygen from the oxides of magnesium, zinc and iron. This is due to the fact that copper reacts with oxygen less readily than these metals. It is the least reactive. A more reactive metal removes combined oxygen from a metal oxide of a less reactive metal. More reactive metals displace less reactive metals from their oxides. From the above experiments, the following observations are noted. Magnesium displaces the following 4 metals from their oxides: copper, lead, zinc, and iron. Zinc displaces the following 3 metals from their oxides: copper, lead, and iron. Iron displaces the following 2 metals from their oxides: copper and lead. Lead displaces only copper from its oxide. Copper does not displace any of these metals from their oxides. Therefore, magnesium is the most reactive while copper is in the least reactive. By considering the number of metals displaced, a reactivity series similar to the one developed earlier can be obtained. Magnesium has the highest ability, followed by zinc, then iron, then lead and copper respectively. The removal of oxygen from a substance is called reduction. When a metal oxide loses oxygen, it is said to have been reduced. The metal, which gains oxygen, is said to have been oxidized. For instance, in the above equation, zinc is oxidized while copper oxide is reduced. Both reduction and oxidation take place simultaneously. The extraction of metals from their ores uses the concept of reduction. The ores that contain the metal oxides are reduced by more reactive metals. For example, aluminium is used to reduce iron oxide by the thermite process. Carbon, a non-metal, can remove combined oxygen from some metal oxides such as iron oxide and copper oxide as shown. The ability of carbon to reduce some metal oxides is applied in the extraction of metals such as copper and zinc from their ores. Atmospheric pollution. Human activities have changed the composition of air in some places. Gases such as carbon-4 oxide, carbon-2 oxide, sulfur-4 oxide and phosphorus-5 oxide are examples of harmful substances emitted into the atmosphere mainly from the combustion of fossil fuels. These gases cause pollution of the atmosphere. For example, sulfur-4 oxide dissolves in rainwater and is converted to sulfurous acid, which forms acid rain. Acid rain destroys plants and aquatic life. It also corrodes iron sheets, zinc roofing and buildings. Uses of oxygen. Air enriched with oxygen is used in hospitals by patients with breathing difficulties. When mixed with helium, it is used by mountain climbers and deep-sea divers. Oxygen is used to burn fuels such as those used for propelling rockets. A mixture of oxygen and acetylene burns to produce a very hot flame used in welding and for cutting metals. During steel making, oxygen is used to remove iron impurities. Oxygen is used as one of the reactants in fuel cells. Thank you for watching this chemistry lesson. Please subscribe to this channel and other Genius channels relevant to your level of study.